Good morning, guys. Hope you are doing good. So, today we are going to deal with one of the very important topics, which is soils. Fine. So, within soils, we are going to talk about different dimensions like definition of soil, physical and chemical properties of soil, texture of soil, acids, bases, and their role in the formation of soil profile, factors influencing the formation of soil, and then soil genesis, which is nothing but formation of soils. And then types and distribution of soils in India, soil erosion and conservation measures. So without any delay, let's start with the definition of soil. So what is the layman definition of soil? Soil is nothing but upper weathered layer of earth crust, which is nothing but a parent rock. In other way, for example, let us consider a basalt rock. The disintegration and weathering of this basalt rock will lead to formation of its soil, black soil. Next, let us consider metamorphic crystallized rock. And now, disintegration and weathering of this metamorphic crystallized rock will lead to the formation of red and yellow soil. And the color of this soil depends upon the iron content in that soil. The more the iron content, red it is. The more red it is. Fine. So this is about what is the definition of soil, upper weathered layer of earth's crust. Apart from this, the other thing is it is a dynamic entity, which means it undergoes continuous physical and biological changes. Physical and chemical. So physical in the sense it undergoes weathering, mechanical disintegration. Chemical means it undergoes salinization and then exchange of acids and bases. And then biologically, it is related to the formation of humus. So overall, we can define soil as an upper weathered layer of earth crust and a dynamic entity which continuously undergoes physical, chemical, and biological changes. Now, after discussing the definition of soil, let's move on to our next dimension. So the next dimension is about physical and chemical properties of soil. In brief, soil consists of three components. One is solid, and then liquid, and the matter in gas state. The solid is further categorized as organic and inorganic matter. The organic matter is derived from humus, which is like leaf litter and all, from the plants and the remains of the humans. And then inorganic, it will be derived from, so it is derived from the weathered material of rocks. Weathered rock material. Fine. So liquid is nothing but water. In technical terms, we call it as soil moisture. Fine. So gas is about atmosphere. Now, how these things play a role in the formation of soil? So one thing is, generally what happens, let us consider that a region has experienced a rainfall. Fine. This is the upper layer and this is the bottom layer of the soil. So this is region A, it experienced rainfall. So first step is what? This upper layer will be filled with water. Fine. Let us consider this are the rocks. So it got filled with the water. Fine. This is step number one. And next what happens? The water which got filled in the upper layer will be percolated down. Right? So now what happens? The bottom layer will be filled with the water. Fine. So this is topmost layer. Now the bottom layer will be filled with water. Even it consists of rocks, obviously. So now what happens? The open pores between the sediments in the upper layer will be filled with the atmosphere, which is gas. And the bottom layer is filled with water. Under these circumstances, wherein the upper layer has the pores of the upper layer is filled with the atmosphere and the bottom layer is filled with the water, then we can say that the soil has reached the field capacity, which means it has enough fertility to support any crop. Fine. So this is about rainfall. Now let us consider what happens in the dry conditions. Fine. So this is a top layer. Whatever the moisture the soil has in this top layer will be evaporated. Fine. So whatever the soil, like moisture the soil has in the top layer will be evaporated. So this is first step. In this step, the bottom layer still has its moisture or the water, we can say. Now, due to capillary action, what happens? Whatever water content the bottom layer has, it will upwell towards the top layer, and eventually even it will get evaporated. Now what happens? Finally, both top layer and the bottom layer will be filled with air in this case. Fine. So here also it will be air, even in the bottom layer also in this, like the pores are filled with air. So this condition is called parched soil. Fine. So this is about physical and chemical properties of soil. Now let's move on to our next dimension. So our next dimension is soil texture. So our next dimension is soil texture. Now, depending upon the size of the soil particles, it is categorized into granules, and then sand, and then silt, clay, and then colloids. Fine. So the size of the particle of a sand or a soil reduces from granules to colloids. I need to say granules are larger. Colloids are very tiny particles. Fine. So the granules are very large cobbles and bubbles. We hardly consider them as a part of the sand texture. So we won't include them as part of soil texture. Now remove it. Now colloids are very tiny particles, so we avoid them while talking about the soil texture. Now the soil texture is solely depends upon the content of or the proportion of sand, silt, and clay. If a soil has equal proportion of sand, silt, and clay, then it is called loamy soil. If it has higher proportion of sand, then it is called sandy loamy. And if it has higher proportion of clay, then it is called clay loamy. Now let us talk about what happens when the soil is clay or a clay soil. So in clay, the soil particles are very densely integrated, we can say, fine, such that it does not allow downward percolation of water. Downward percolation of water is not possible in clay soil, which leads to waterlogging condition. And the waterlogging condition favors which crops? Paddy or rye crop. Fine. Now, what happens in the sandy soil? So, sandy soil, the size of the particles is large. Fine, compared to silt and clay. So, the gap between these particles will allow this downward percolation of water, which leads to no stagnation of water. So now it's about which crop? Wheat crop. Fine. So these are the certain minor things which you won't find in your regular textbook, but still you're supposed to know. Fine. So now this is about soil texture. Now let's move on to our next dimension. The next dimension is about colloids, acids, and then bases. Fine. Regarding the acids and bases, we have been studying it since childhood. Now it's time to know what exactly their role or their function in the formation of soil. Fine. Now first let us talk about this unknown term, which is colloids. Colloids are nothing but very tiny particles. Fine. So very tiny invisible particles, they are actually formed because of organic, either organic or inorganic. Fine. If they are completely of organic, then they are called humus colloids. If they are completely of inorganic, then they are called clay colloids. But in practical terms, it will be a combination of both clay and humus, which is called clay humus colloids. Fine. So what is the thing about this colloids? Colloids are the very tiny particles, consists of both organic and inorganic, which is clay and humus. Now, these colloids are negatively charged particles and has very large surface area. Now, how does it make sense to our discussion? Now, this is a colloid. Fine. So, this is negatively charged, has, and as a large surface area. This negatively charged colloids will attract the positive bases, calcium ion, sodium ion, magnesium ion. So it will attract the bases and it will hold those bases in a very light way. It will hold those bases very loosely. Fine, such that they can easily extracted by the roots of plants. Fine. So yeah, let us have a diagrammatic representation of it. Yeah. So this is the top surface of the soil and this is a tree. Fine. So now here there are colloids. Fine. So this is negatively charged, as I said. It has what? Bases around it, loosely held. Now the roots of these plants will reach this colloid and it will extract these bases from these colloids and use those bases for its growth, because bases is nothing but the nutrients which are very necessary for the plant growth. So now we just imagine what will be the situation if there is an absence of colloids. So that is how your learning process should be. So this is about colloids. Now we have been taught that when the soil is acidic, we are supposed to add lime to it. But why is that so? Yes, we will add it, it will increase the soil fertility. But how does it will increase the soil fertility? Now the topic is, or the concept behind that is, so generally what happens in certain circumstances, the H plus ions, which are nothing but acidic ions or acid ions, that will replace the base of that base around this colloids. So what I am telling is, so if it's a colloid, so in this case, what we had the bases. These bases will be replaced by the H plus ions in under certain circumstances. Fine. Now the bases doesn't have a capacity to replace the H plus ions, which makes the soil eventually acidic, which is infertile. So it won't support any crops. So now we are supposed to make this acidic soil fertile. So for which we add lime. What does this lime do? Which is nothing but like calcareous material. Now this calcareous material has the capacity to replace this H plus ions with the calcium base ions, which eventually makes soil fertile. Fine, got it? This is the reason that we add lime to the acidic soil to make it fertile. So from this we can extract that the calcareous soil which we found in the arid and semi-arid region is fertile in itself. Fine. It doesn't require much nutrient to make the soil fertile. But the question is, we are saying the calcareous material or the calcareous soil is very fertile, and the calcareous soil, we will notice that calcareous soil in arid and semi-arid regions. Here comes the hypocrisy. What? The arid and semi-arid regions, we hardly find vegetation. This is because of absence of soil moisture. This is not about that soil is infertile or not. So the absence of vegetation in the arid and semi-arid region is because of absence of water, not because of infertility of soil. If you provide enough moisture or the irrigation facilities to the soil, then they will give you a bumper crop, which we observed in the Indira Gandhi canal project. Fine. This is about colloids, acids, and bases. Now let's move on to our next dimension. So the important part of the soil, which is soil profile. Now, what does the soil profile mean? It is nothing but the vertical cross section of soil. Fine. So vertical cross section of soil, which consists of horizontal layers called horizons. Fine. Before getting into the details of soil profile, we are supposed to know a few processes, which is like leaching, erosion, and illuviation. So leaching and erosion reflects the same in general. For example, it is nothing but washing away the nutrients. The process involved in washing away the nutrients will demarcate the leaching and erosion. For example, groundwater removes what? Limestone, karst topography, which leads to karst topography. Fine. Now the point is how it removes, it dissolves limestone into the groundwater and it eventually, washes away as a part of water. Like dissolution is taking place. Chemical action is taking place here. So removing by dissolving the material in it. Whereas in elevation, it is a mechanical process. Whereas the water washes down the material. It won't dissolve matters in it, rather it washes down with its potentiality. Fine. Like mechanical process. That is the difference between leaching and elevation. Elevation is nothing but whatever the material has been leached or elevated, that will be deposited at some point, right? So that deposition process is called elevation. Fine. So having discussed about leaching, elevation, now let's get into the soil profile. So this is O layer. Fine. So what does O layer consist of? O layer is nothing but organic layer. Fine. The top layer consists of the leaf litter fallen from the trees. Fine. This is not decomposed, undecomposed organic matter. Leaves or something, undecomposed organic matter. Whereas in the bottom layer, even it is also a part of O layer, O horizon, but it consists of slightly decomposed matter compared to the top layer. Now let's move on to the next layer, which is A horizon. Sorry. So what happens in the A horizon? So here, whatever the humus happening in this O horizon will be percolated downwards, and the nutrients will be percolated downwards in the A horizon, which makes the horizon A fertile. We can say nutrient rich and humus rich. So trees which have the shallow root system will take nutrients and humus content for its growth from this horizon A. Next comes the horizon E. So now what happens? The water which are percolating down, fine. So that will wash away certain portion of A, whereas it intensely elevates the horizon E. Fine. So here elevation happens, but it will be gentle, we can say. Whereas in E horizon, it is intense. Fine. So finally, everything, the least material from A horizon and E horizon will be deposited at B horizon, which eventually makes it nutrient rich and humus rich. Fine. So whatever material has been leached in A horizon and E horizon is being deposited in the B horizon. Now, the plants which have deep roots, that will take nutrients from B horizon. Fine. So next comes the final layer, which is C horizon. C horizon, it is nothing but the disintegrated material of parent rock. Fine. But it is not disintegrated to such an extent that it forms in soil. Fine. It is like a large block structures. So here it is parent rock. Finally. Fine. So from this we can say that C horizon will extend at the cost of parent rock downwards. Fine. So this is about soil profile. So till now we had a discussion about definition of soil and physical and chemical properties of soil, texture of soil, colloids, acids, bases, and soil profile. Fine. And rest of these things let's discuss in our next video. Fine. So stay tuned and subscribe to get the update of the next video. And stay safe, stay home. Thank you. Have a nice day.